Vanakkam. Welcome to this course on classics in neuroscience. We have been looking at classic Nobel Prize winning works, and in this series we will be looking at the classic Nobel Prize winning works of Robert Barany. And we know what his contributions are. Essentially his contributions led to the improved understanding of brain's balance system, and who explained how vertigo and ear brain connections worked, and was awarded the 1914 Nobel Prize in Physiology and Medicine for his phenomenal contributions to this field. In this class we will look at vestibular compensation and motion sickness, and the connection of motion sickness to inner ear and brainstem and vestibular system connections. Barany essentially discovered that if a person loses function of one vestibular organ, then the brain can gradually compensate for the loss by exploiting the information that the brain receives from the other vestibular organ. He noticed that patients with inner ear damage initially suffered from severe vertigo, but eventually regained the ability and to balance and stability over time. So this was one of the first demonstrations of neuroplasticity in the vestibular system. In the brain in general, recall in our discussion on Cajal how his work essentially laid foundation to the explosive growth of neuroplasticity. The idea that there are individual neurons whose connections can vary depending on experience, that is neuroplasticity, right? So those who have the inner ear damage initially suffer a lot, but with time they improve, meaning that is inner ear damage on one side. If there is inner ear damage, say for example on the left side, then the system, the brain, tries to exploit information only from the right ear. A sort of sensory reweighting happens, such that this information, the information coming in from the left ear is suppressed, and the information coming in from the right ear is given precedence to. So people sometimes naturally recover their ability to balance themselves and their stability, showing there is an inherent ability of the brain and the nervous system for restructuring connections and for reweighting of the senses. This is an excellent example of neural plasticity in the brain and the nervous system. So the ability to reorganize for balance deficits, showing that there is a scientific basis for performing rehab therapy, vestibular rehab therapy, still used today to help patients recover from vertigo, stroke and traumatic brain injuries. Essentially, Barany linked motion sickness to conflicting signals, what I called as sensory dissonance some time ago, conflicting signals that the brain receives from eyes and the very strong, very well developed the gyroscopic system, so to speak, the biological gyroscope, that is the semicircular canal, and the brain. The brain cannot process this, because it turns out that the semicircular canals of the inner ear are an excellent and a very reliable source of the sense of orientation for the brain. If the visual input is conflicting the information coming in from the semicircular canals, the brain cannot process it so easily. This dissonance is what causes motion sickness. He discovered that motion sickness occurs when inner ear senses movement, but eyes do not sense movement simply, or the other way around. He performed experiments in which he spun patients in rotating chairs and observed their reactions. By the way, if you perform this experiment with eyes closed, eyes open, the results will be different, obviously. So his research led to the development of this medications for motion sickness. Explain why reading in a moving car can cause nausea. That's why you should not read in a moving car. You can read in a moving train, but not in a moving car, because the inner ear detects motion, but the eyes see a stationary book. Well, if it's a vibrating, if it's in a bus, that's different, but if it's in a moving car, it's different. His work essentially influenced space medicine, aviation medicine, leading to improved pilot training to prevent disorientation. By the way, this is extraordinarily important. It has critical consequences for lives of so many people. And modern impact, essentially, his findings are still being used in virtual reality based motion sickness treatment and space medicine, helping astronauts avoid motion sickness in zero gravity. His work essentially helps military design motion sickness, anti-motion sickness training programs for fighter pilots and sailors, because when fighter pilots are going, suppose they are engaged in a dogfight, the plane may rotate in many different directions, but the pilot should still be oriented towards that. If the pilot loses orientation, then it is possible that the pilot's life will be compromised, but also that very expensive war machine will also be compromised. So, specific motion sickness training programs for fighter pilots and sailors and astronauts. So, he mapped out the connections that the vestibular system makes to the brainstem and the spinal cord. He discovered that vestibulospinal reflexes, the neural circuits that help us keep balance when we move our heads. I make movements of the head, but I am looking at a particular point. Let's say I am looking at the camera. As I am looking at the camera, I am rotating the head, but my eyes are moving in the opposite direction. So, essentially a change that happens in the eye movement. So, I move opposite to the direction of the head if I would like to fixate on a particular object, but this is not the vestibulospinal reflex, this is the vestibulo-ocular reflex. Similarly, a variant exists for the vestibulospinal reflexes. It turns out that critically, the vestibular nucleus happens to be the only nucleus that can serve as both the input and the output nucleus of the cerebellum. This is a matter of detail. I will request my teaching assistants to post some videos relevant to this detail physiology from my previous course on neuroscience of human movements. So, TS, please note, please post videos related to cerebellum and the vestibulocerebellum, flocculus and nodulus in the cerebellum at the base of what constitutes or appears to be the cerebellum is called as the vestibulocerebellum. And it turns out that the vestibular nucleus can serve as both the input nucleus and the output nucleus. This is the only nucleus that can serve as both the input nucleus and the output nucleus. The other output nuclei of the cerebellum are the dentate nucleus and the emboliform nucleus and the globose nucleus and the fastigial nucleus. So, these are the 4 output nuclei, but the one nucleus that serves as the output nucleus of the cerebellum that is actually located outside the cerebellum is the vestibular nucleus. For all practical purposes, this is an output nucleus of the cerebellum, but it is not located within the cerebellum. The rest of the output nuclei of the cerebellum are actually the so called deep cerebellar nuclei. These are nuclei that are embedded within the cerebellar cortex, not the cerebral cortex, the cerebellar cortex. The details I have given as a series of lectures in my course on neuroscience of human movements. I will request my students to post relevant videos to that. So, Barany studies essentially helped doctors to understand how brainstem injuries affect balance, posture and coordination. Essentially, injuries to this region of the brain, especially the vestibulocerebellum, affects balance and posture and coordination, essentially helping neurosurgeons to pinpoint injuries more accurately, provided key insights on how the body adjusts postures, because there are different parts within the cerebellum that function, that serve different types of functions. The cerebrocerebellum, the spinocerebellum, and the vestibulocerebellum. The details are outside the scope of this course and this video, but you can go through my other videos for those who have the interest. And essentially his discoveries made a profound impact in neurosurgery, vestibular rehabilitation, and providing physical therapy for people who have had spinal cord injuries. So this also helped to study Parkinson's disease, multiple sclerosis, and other such diseases of the nervous system. So in summary, Barany's work on this, in this field, essentially described vestibular compensation, how there is a vestibulospinal system influenced compensation, and then vestibular ocular reflex compensation. There is a definitive causal relationship between motion sickness and inner ear connections, and there is brainstem and vestibular system connections. With this, we come to the end of this video. Thank you for your attention.